Welcome back to the Innovation by Design podcast, where we explore how design thinking drives innovation across the architecture, engineering, and construction industries. I'm Evan Troxel, and once again, joined by my co-host, Candace Kitchen. Candace, how are you today?
Doing well, Evan. Thank you. It's good to see you again.
You too.
Today, we're joined by Dr. Matias del Campo. He's a Chilean-born Austrian architect, designer, and theorist known for pioneering work at the intersection of architecture and artificial intelligence. Really excited for the conversation today. So, Matias, if you wouldn't mind just starting out, tell us a little bit about your journey, how you came to be where you are.
Okay, I'm going to start at the university. I think that might be a good point, and I'm going to try to make it quickly after that. When I was a freshman at the University of Applied Arts of Vienna, my professor, Hans Holland, selected about 5 or 6 students to work on a computer, which was a new thing back then. So everyone was still doing plans by hand and ink, drawings, and beautiful. But this innovation was coming. And I was under these 5 lucky students. So he sat me in front of a computer and basically said, just do something.
I figured this out.
Figure this out, exactly. So just do something. In reality, there was also a little bit of help. We got courses in programming in Unix and things like that. And this was like my first encounter with computational design. And like after being trained for about a month, I started to think, and basically my head exploded. It was like, okay, this is amazing. This is incredible. I can think of things in my head. I can visualize them in the computer. I can make them accessible to other people. So I thought, that's amazing. That's it. That's going to be the rest of my life. And I stuck to it. So basically, I continued doing this throughout my studies. And then when I graduated, I actually wanted to go and work for an architecture office that uses computational tools. But I very quickly figured out that that doesn't basically exist in Vienna. At least it didn't back then. And so I thought, well, I'm going to do it myself. So I founded this company together with my partner, Sandra Manninger, called SPAN, which was specialized from the get-go in using computational tools for architectural design. We did various competitions. We started teaching. And we already knew each other from the time when we were studying. And it was still during my studying time that I encountered for the first time somebody who was studying computer science, and more specifically, artificial intelligence. There was 96, 97, something like that. And I immediately thought, that's really interesting. So we started to discuss with him and his professor about completely speculative how to use it in computational design for architecture, which was impossible back then because there was just neither the algorithms, nor the computational power, nothing of that existed. But just theoretically, it was interesting. Then move ahead time. This was still when I was a student in Vienna, and I'm going to jump over now to when I started to teach in the States. When I went to Michigan to teach at the University of Michigan, which was absolutely amazing, by the way. And I got in touch with people from robotics at the university, and they were specializing in things like machine vision, object detection, because they were working for example, automated cars, robots for the industry that has some sort of detection of things. And this really created this enormous step forward for me. I learned so much from these people, like how AI works, how like a neural network is set up, how you set up data sets, where you get the data from, how to process it. So like the complete basics of how artificial intelligence really works, I have to say I learned that from my colleagues and friends at the University of Michigan. And this, I would say, that was like the second explosion in my head. After this first encounter with the computer, like this first serious encounter with AI was absolutely incredible. This was around 2018, I would say, 17, 18. And I saw like, okay, these ideas that I had back then about how to use it, I think we can do it now. And so I started with this laboratory at Taubman College called the Architecture and Artificial Intelligence Lab, ARIL, together with my partner Sandra Manninger and several other colleagues, primarily colleagues from computer science, robotics, data science. So it was an interdisciplinary hub where all these people came together to think about ways of how we can use these new tool sets in architecture, in a sophisticated way, meaning doing things like, for example, how can we improve plans of social housing around the world by providing tools that allow architects to optimize them towards particular goals. Creating our own data sets, because we knew that a lot of data sets have the problem of bias in them, which we can try to avoid if we build them ourselves. Yeah. And this was also work with students in Michigan. So I have to say, the students in Michigan are an incredibly courageous bunch of people. They jumped on the opportunity to experiment with artificial intelligence before this whole thing became a hype. So they recognized very quickly that there is something there that might influence the rest of my career. And I think they're right about that. And a lot of these early students that we had in the studio between 2018 and 24, I would say, became immediately very sought after. So most of those students actually had already an offer for work before they graduated, because officers had heard that they are learning about how to use AI. This is like, so I made a huge jump between my studying time and today, basically. And now I'm here. In the meantime, I also wrote several books on AI and architecture, basically trying to figure out what's the theoretical basis of all of this for us architects. It's not just a tool. There's a variety of other aspects that come along with it. Like if we have a tool that can, so to speak, design, and has a form of intelligence, does it mean that humans are unique or not? So it questions a lot of the things that we take for granted as humans. And by doing so, it actually creates a huge plethora of philosophical problems that I think are going to define the conversations on design philosophy, but also any other area of human existence, no matter if it's ecological, biological, ethical, economical, political, like all of those things that there is like a whole history of philosophical thinking are getting, like how to put it?
Like re-examined.
Re-examined, that's very good. Thank you.
Yeah.
Yes. And it's an exciting time, I would say.
Can let's jump back to just defining what computational design is. I think there's going to be audience members who don't know what that means, because I think when people think of architects, and you started off talking about like the very traditional training of architects, right? Drawing with pencils on vellum, pencils on mylar, ink on mylar, and drafting tables. And, I think that image still exists today, even though it's just moved to the drafting board is now CAD and even BIM, right? Where it might be more 3D modeling based, and the drawings are derived from those 3D models. Computational design is like a subset of an architect's tool set, right? It is not necessarily the all-encompassing architecture. And so I'm just curious if you could just spend a few minutes kind of, defining what computational design is and how it fits into the practice of architecture.
I don't know if it's still the case, but if you go to Wikipedia and you look up architect, the first image that comes up is a 19th century etching of an architect standing in front of a huge board drawing with like rulers and compasses and stuff like that. Sure. And I think this is really still the definitive idea of the architect in the people's minds. But computation design basically when it started, it basically took those tools that existed, like basically the drawing board and the ruler and the compass, and basically translated them onto the screen. So basically, instead of using those physical items like the vellum that you mentioned, the paper, the ink, the ruler, all those things became digital, computational, right? And at the beginning, what we did was just basically translate what we did before manually into another tool. That was the start of it. But very quickly, some architects, some people started to recognize that we can do much more than that, because we can automate processes, we can calculate faster, we can include structural calculations and cost estimates. And then also suddenly, because of the influence from other disciplines like car making industry or aviation, who have been using these tools for decades before architects, we started to understand that you can rationalize more complex figures, that you can basically build things that we couldn't build before because of computational design. Good example is Frank Gehry, for example, right? Frank Gehry makes these incredibly highly complex buildings, but they're still on budget and on time because he's using computational tools to execute them.
I was just going to add one of the words that you said earlier was algorithms, right? And algorithms are basically like a codification of a set of rules to define whatever it is that you're trying to imagine, and then ultimately get into maybe a 3D model and eventually drawings so that something can be built. The rules used to exist inside architects' head, right? Architects who had experience had their own kind of spatial rules and the way that they did things and the building codes that they knew, and they would apply those kind of in real time as they were designing. Algorithms now are the codification of that, and I think the power of that is scale, right? Because now a junior designer, if that knowledge has been codified from a senior architect, now has access to apply those rules through these more, computerized systems that then show up during the design process. And I just wanted to point that out because these rules have always existed. They just didn't always exist in the computer. And I think that's where we start to see kind of the application of these rules by more people. Whereas before it was probably a fewer set of people that would double check the junior's work and apply the rules or even set them out ahead of time.
I mentioned before that briefly after we finished studies, Sandra Manning and I founded our company SPAN immediately as architecture office. Mm-hmm. And I have to say that one of the things that was very alluring to us in regards of computational design was that because of the different ways or the different methods of working, you suddenly became much faster in doing things that you could do before. And that meant that we as a very tiny office could compete with very large companies for projects because we could basically suddenly process things that normally you need a team of 10, 15 people. We could do those things with a team of 3 people, 4 people. Yeah. And I see a similar problem emerging now, like that people say like, okay, if I use AI, I can just, do much more in much shorter time with much less people. But there was certainly something that for us at the beginning was important. What you mentioned is, absolutely true. It's the algorithm that basically defines a rule set that you want to apply to a building or to a design. Existed beforehand, of course, in the mind of the architect, it's true. And you could basically, computerize it, so to speak, and apply that to your designs. And this is also basically, but there's a distinction between, by the way, there's a distinction between computerized and computational. These are 2 different things. So computerized, for example, let me go back to Frank Gehry because there's a good example for that. Frank Gehry is a good example of a computerized architect, meaning he like in the Simpsons episode where he just takes his piece of paper and just does this here and throws it away. And then suddenly that becomes an opera house. That's exact. I mean, it's a funny thing. It's a meme by now, but that's basically how he works, right? He's an artist who basically creates a sculpture, and then he has a team of people who computerizes the sculpture, meaning they scan it and figure out how it's put together, and then they basically build it. Computation design is different in that it also relies on emergent methods of designing, meaning you have a rule set, and then you let something grow out of that rule set that defines the shape of your design or the program of your design. So it relies a lot on, let's say, biological algorithms that, how do trees grow or flowers grow? We understand how these rules work. There are mathematical rules behind that. And we can basically take this method and then apply that to building design, for example. Mm-hmm. Yeah. So it's not so much from the mind of the architect as a unique artist or genius, but rather a collaboration between a mathematical toolset and my decision abilities as an architect and designer to say, this is interesting, I like this, it's beautiful, let's do that. Yeah. It's a strange collaboration between a human and a non-human intelligence.
I think that's really cool. It speaks a lot to the scale that you both were kind of talking about. But one of the things that you mentioned earlier was that you learned a lot from the students at the University of Michigan. And we're actually working a lot with students at Michigan Tech. And we have found that the ideas that are coming from these students are incredible, really unmatched. Do you see yourself working with students in the future, again, as your company evolves and as AI, of course, evolves because it's ever changing?
I mean, I still teach. Right now, I'm a guest professor at the Technical University in Vienna, which is a very interesting and challenging position. Yes, they've been working with AI before, but I'm trying to introduce these methods of thinking around it that allow students to exactly do what you just described, coming up with these incredible ideas. Because for a student to come up with an incredible idea, the first thing he needs is information. Like, how does the thing work? What can it do? How can I, use it against the grain, so to speak, for example? Like, how can I resist it? How can I use it in ways that we were not thinking before? And I think students are very good in this kind of challenging the status quo of a technology and basically coming up with something that you didn't think about before. It's, of course, also the freedom of naivete. Too, of course.
Beginner's mind.
Yes, beginner's mind. But there's nothing wrong about that. It's just I think that it's very helpful for you to.
It's an
develop your
advantage
abilities.
Sometimes. Yeah,
I agree.
Certainly.
Yes, it is. Yes. So I definitely gonna continue working with students. Yes.
I think one of the things that's interesting to me, and I would be curious to hear from you as a practitioner, but also as an educator, we go back to that beginning story about the training of an architect and how you might approach a design problem historically versus what you're seeing now as the innovation in the practice of architecture applied to the design process. Could you kind of explain those two different, the evolution of that maybe? And it doesn't have to be every step along the way, of course, because it's been a long evolution. They say architecture is like one of the oldest professions, right? So, but if you think about just from when you were in school and being trained traditionally and then being sat in front of a computer and saying, okay, figure this out, to where you are now, it's quite a different story. And it's not all about just being able to go faster, right? It's not just about that. There's all kinds of different nuance to the way that architects approach a design problem. Some of it is the same, and some of it is very different because of the tools that we have nowadays.
As like many other disciplines, architecture, of course, has experienced like enormous changes in the last 30 odd years. Yeah. And they introduced the introduction of computation is one of them. But I think that the way I was educated as an architect was partially traditional, partially absolutely not traditional. So on the one side, the conventions of architectural design, like being able to read a plan in a section and understand what is what in it and how do I reproduce that. Also, how can I construct my own plan for my design out of it? I think this is still a very useful ability to have. And I still think that the plan, the section, the elevation are like the universal language of architecture around the world. Every architect understands what is meant by certain things in a plan or a section. So it's a useful tool to have, especially if you want to work internationally as an architect. Being able to develop these sort of spatial sequences in your head that at the end will define the quality of the architecture, I think also that is still a very good thing to train your three-dimensional, your four-dimensional thinking methods. The tools just changed. Yeah, the tools, how we express this. So on the one side, you have the architect as this sort of like artistic, philosophically educated person that basically understands parts of economy and of ecology and society, and thus is able to somehow extract from that a material presence, which then becomes a building that somebody will inhabit or use in some way, shape, or form. That's one thing, right? So this is like this. The architect is the cultural figure, so to speak. That also, for example, sometimes even tastes his clients what taste is. Teaches his clients about that. And then on the other side, you have this sort of like technological genius, right? This person who knows that, you know, how to lay bricks or how to pour concrete and how long it's going to take to cure and which materials I can use outside on a building and which ones would better inside, like all
the
the
science. Yeah.
Yes, the technical aspects of architecture. And I still also think that those are important as an architect to know still. Because yes, you can ask an AI, what material can I use? And it's going to give you like a 15, but you still as an architect will have to decide which one. Yeah. And also, by the way, you still should have the mental capacity to understand if an AI just is hallucinating or not, because it also can be that it comes up with things that don't exist actually. Yeah. As a side note, you can exploit that too. I think that the architect as a form of cultural figure will still continue to exist and to shape things. I think that the architect as sort of like a technical genius might start to erode because of the possibilities of artificial intelligence. I think that the whole idea of the star architect is dead, as dead as this can be. I don't think that this system has any reason to exist in the current concept, in this current new condition, because what if AI made anything clear, is that the soul genius does not exist. That this idea of the genius that we had as humans is obsolete. That this is an idea that cannot be maintained anymore. It's a very wasteful way of thinking about design and architecture, in my opinion. I think that architecture always has been a collaborative effort. The star architect was just a strange notion that we somehow created for a process that in this way does not exist. Not a single architect does his whole design alone. That's just not how architecture works. Yeah. And it has become even more visible with the introduction of these innovative toolsets that we see now. So I have the feeling that we are standing on a threshold in architecture where we have to make clear to ourselves which way we're going to go with these new toolsets. I know that there is also a lot of resistance from architects for these tools because they are afraid that it will take away their agency over their design, which I don't think is true. I think they're not informed enough to make that decision. I don't think that the fear is necessary. I have a very interesting anecdote here. When I started to do my courses on AI in architecture in Michigan, one of the first questions that I always got from students was, when I graduate, will I still have a job? Because they were all afraid they might get replaced. Yeah. When they finished my course, no one of that would ask that question ever again, because they knew that how much it's necessary, how much human input is necessary to do something meaningful with AI.
It's almost the idea of like it's only as useful as like what you put into it.
Yes.
But okay, so in an ideal world, everything goes perfectly. Everyone knows their role. Everybody's putting in what they're supposed to be putting in. Like, explain to us, what does that truly look like? What does that ideal relationship truly look like in your mind?
There's a very beautiful book that was published maybe 2 years ago by James Bridle called Ways of Being. Yeah. In this book, he basically describes a variety of different intelligences that already exist on our planet. And this goes from examples from squids and plants, forests and geological formations and mushroom colonies, insect colonies. Like it's astonishing how he basically unfolds this whole world around us where there is different forms of intelligence already at work, but that we as humans ignored because we had this project of the uniqueness of humanity. Yeah, which was the big thing since the Enlightenment, where there was like this very clear distinction that the human is on top of the pyramid and then everything below that has to be subservient to the human. Yeah. Thus, there is no way that anything else except humans can have intelligence. And of course, there is speculations about intelligence outside of our planet, but of course also artificial intelligences. Yeah. So what I see emerging right now is on the one side, the end of that humanist project that we know since around 1620, 1630. In architecture, for example, Wittkower wrote about this extensively, the humanist project or architecture in the age of humanism. and that this whole idea, this whole philosophy of the human uniqueness is coming to an end because of this. This is not bad. This is actually very liberating. This is a point where we can finally lean back and say, well, if there is other intelligences, maybe they also can take some responsibility for our planet too, instead of just us. Yeah. But on the other hand, it also means that we have responsibility for them too. Yeah. So it's a very strange thing that's just happening. It's a small philosophical circle of people that are discussing this. Actually, it's not so small anymore. It's growing quite quickly. So this, for me, this whole project with AI is more like it's more and more not so much about the technology, but about what it means for us as humans. Like, how can we reflect on that discovery in a meaningful, intelligent way that will hopefully increase our understanding of the world. And I mean, this is, at the end of the day, that's all that philosophy and theory wants, is understanding the world better. Yeah. Long story short, I think that the emergence of these new tool sets, the emergence of artificial intelligence, is basically introducing or facilitating a novel way of thinking about ourselves.
You spoke earlier about that resistance that some in the industry have against any kind of new tools. It doesn't have to be specifically AI. We were talking about AI in that context. This has happened many times before we got to AI. This happened with digitization. This happened with BIM. This happened with computation. With all of the, various, different kind of methodologies and tool sets. There's always kind of been this bifurcation in our industry of the educational side with the practice side, as far as what the education side prepares people for when it actually comes to practice. And you're bridging all of this. You're bridging the technology, the tools, the education, and the practice. And I'm curious just what you think those two sides, education and practice, need to address with this new game that's actually in play now. Like, to me, this is bigger than just adopting new tools. Like you said, this is forcing us to ask kind of philosophical questions about these discoveries. And then we're seeing it play out across many industries in various ways, right? Some are very forward in addressing this, and I think architects are kind of watching from the sidelines, at least many of them, not everybody, but watching from the sidelines to see how it plays out. And then there's architects like yourself who jumped in early and are actively looking for ways to apply this to the practice of architecture and see how it could not just differentiate you, but take your architecture to the next level. So I'm curious what that stirs up in you, and what you see the academia side and the professional side needing to do to move forward, or what maybe you could just paint kind of an ideal picture of what you think the possibility could be there, because who knows how it's actually going to play out.
Yeah. I think your last comment is the best one. Who knows how it's going to play out? We don't know yet. So we're going to see where it's going to go. But let me go back a little bit to your comment about the resistance to new technologies, and not only in architecture. I mean, it's a common thing, right? I mean, think about the invention of photography in the midst of the 19th century, like how much pushback there was for photography, because every artist thought they're gonna lose their job because the camera can do the things that artists were doing much faster and cheaper. Yeah. Or before that, the Luddites, who basically destroyed machines because they thought they're gonna take away their jobs. Yeah. So these stories repeat over and over again.
Right.
It never ends so well for the people who resist, by the way, if you look at it historically. So I'm not saying that resistance is futile. I'm not a Borg. But I would say that there is I understand the resistance in parts, yeah. But one thing that I repeat in lectures that I do over and over again to architects, I tell them, if we do not engage with it, somebody else will do it for us. Yeah. That means developers, investors, construction companies will take over the role of architects because they can take AI and automate processes that normally needs an architect. So That means we need to take the opportunity. We need to be the leaders in the discussion. We need to be there and talk about it. We cannot ignore it because otherwise we make ourselves obsolete.
I want to just toss something in there, and that is kind of this idea that I've thought about a lot over the years, which is, something doesn't just deserve to exist. And so in this case, I'm going to apply that to the profession of architecture. The architects themselves have to make the value case for why the role of an architect deserves to exist, because if that isn't well known to all of those other adjacent people in the process of a realization of a project, then you will get replaced with whatever tool can do that job sufficiently. It doesn't have to be excellently done, right? It has to be sufficiently done. There's many people in the development and in the finance side and all kinds of areas where it's like architecture is red tape. We don't see architecture as an added value. Because an architect's stamp is required to do a public building, okay, then I have to do that because of the regulatory process, because architects are responsible for the health, safety, and welfare of the people who occupy the building. But that doesn't mean it's always going to be like that, right? If a tool can actually take on that risk and responsibility, then what are architects left with? And so, to your point, for the architects who are resisting engaging in the process, but also showing the value of what architects bring to the process, then I think we are ripe for disruption in that case. And I don't necessarily, we have to continue to make the case for, in an evolving landscape, that the profession of architecture deserves to exist. We just have to prove that value over and over again, just like everybody else does.
I mean, this is completely true, and this goes exactly to the core of my new company that I just founded recently. It's called Angewandte Künstliche Intelligenz, applied artificial intelligence, basically. Yeah, which provides services to a variety of different companies, not just architects, but a variety of different industries, in providing them with the tools that they need, basically, to improve whatever they're doing in whatever kind of industry it is. Yeah. And we sort of custom design for them AI solutions and storage solutions for their data security. So funny enough, me as an architect now took on the role, basically, to exactly do what you just described before. Basically, what role do I have as an architect now in this new universe? My role is not anymore just to sit down and design pretty buildings. No, my role right now is basically to understand that architects are really good in synthesizing a variety of different things into something that might be new to a customer. Right. Yeah, and this is a talent that every architect, in my opinion, has. Yeah, this half knowledge about everything. Not an expert in anything, but a half knowledge about everything. Yeah, which basically fits really well in this new ecology of AI, because that's exactly what AI also has. Why does it hallucinate? Because it doesn't know what it is, so it makes up something. That's what it's very human in a way. Yeah, we tend to do this too, and that's actually also how many architecture designs came along. Exist. It's this hallucination of something, misunderstanding, misreadings. Yeah. So if architects take their talents, their ability to understand a variety of different fields, and fuse them into something that will provide the client with an innovation that is needed in his business, then an architect fits really well into this new economy. Yeah, really good in this new ecology where you have like the sort of knowledge about AI enough to understand how to create a tool for a client. And in this case, the tool is not a building; the tool is something different. Yeah. A building at the end of the day is also a form of a tool, right? This is an extension of our body. It's to protect our body, right? So I think we as architects have a role in this new environment, but we need to take it on. We just need to not wait. If we wait, again, somebody else will do it.
This idea of solving problems, architects are very, very good at solving problems, and it doesn't have to be an architectural problem to solve it. And so the application that you're talking about, kind of applying it to the business of maybe another architect, maybe a client, whatever it is, that's also a design problem. Right. And it's the design of the business. It's the design of the process. It's the design of the outcome that they're looking for. And it doesn't have to be a building. I think very well put. Yeah.
I love this idea of taking things into your own hands. I mean, you think about all of these conferences that you go to, and the headliner these days seems to be something about AI. And then we kind of all sit in our chairs and we think, now what?
Exactly.
So I agree with you. I totally agree with you, Evan, pointing out that, yeah, just go back to the business, like the business side of things. How can we improve even those small things? You're taking things into your own hands. It's a wonderful concept.
Yeah, it's agency, right? And it's increasingly powerful as far as what's available to many, many, many people to be able to have that agency and apply it to whatever their design problem is. And again, that could be a business, it could be a process, it could be any kind of an outcome. Yeah, absolutely. Well, Matias, I'm curious now what you're most excited about. You just started this company. You have your practice span, your teaching. What are you seeing, unfolding in the profession of architecture that excites you? Obviously, you have your hands in the technology side of thing, but also obviously architecture isn't architecture unless it actually gets built. So, looking across the whole landscape, I'm curious what you're seeing that you're excited about in our industry.
I mean, at the moment, I have to say that I'm so deeply entrenched into this whole debate and technology that I probably cannot see what's really exciting at the moment. It's just it's a bit overwhelming.
You're immersed in the AI side of things. Yeah.
Yeah. So it's I mean, funny enough, I wrote my first book about AI in 2022. It's called Neural Architecture, Design and Artificial Intelligence. And in that book, there was like this sort of fresh, again, the beginner's mind. That book is completely the beginner's mind in a way, because a lot of the ideas that are in this book, I'm working on now slowly, piece by piece, to realize them. Yeah. And I think this is the exciting thing for me now. The exciting part is that I remember how this whole idea exploded in my head. I was like, wow, we can do so much with it. And I started to write down all these ideas. And then now it's like slowly working together with computer scientists and roboticists and data scientists on realizing those and making them a reality that we can use, apply, and show to people. Which also means, of course, writing papers for conferences, applying for patents, building data sets, trying to figure out how we can become a little bit more independent in training our own AI models. How do we talk to clients about it? So out of this fascination that I've had for many, many years, now there's suddenly like a whole new chapter in my life emerging, which I think that's for me probably the most exciting, I would say. Yes, this seeing this unfold into something that might become practical for people to use or to think about or to write about or to resist to if they want to, that's fine for me. But seeing that there's something happening around it, and I see more conferences coming out of that, more books, more magazines talking about it. And I also noticed the level of information is getting better. I mean, how people were talking about AI 2 years ago was abysmal in architecture. I mean, this was painful, honestly. Yeah, because there was so little information on AI in the architecture business that the only thing they were talking about was image generation. Oh, I made a pretty picture. Great, bravo. Well done. Now here's like a list of things you still can do with it, which are much better.
I love that example because I think nowadays maybe that's what the general public or maybe even many architects perceive as the application of AI to architecture is image generation. But could you expand on that and talk about the different ways that AI is touching the profession of architecture and the building industry at large?
Yes. I apologize for the shameless plug here. But I just finished a book. Yeah, okay, not really. I just finished a book. It's called The Architect's Manual to Artificial Intelligence. And it's like 570 pages with examples of how to use a variety of different AI models in practical applications in architecture, meaning from thermal calculations to structural calculations, circulation paths optimization of material behavior, sustainability calculations, optimizing material consumption. With like all of these things are just there for the taking. Yeah, and this is just a small sample of what is on examples in the book. They touch a lot of things from very practical, literally like how do I reduce the material consumption in a design, to the circulation of a whole city. Like, how do I plan the whole circulation within a city using machine learning? And examples from the past. So, to simply put, if you can think of anything in architecture that you have in the form of numbers in data somewhere, you can use it in a machine learning process. And we are an old discipline. As you mentioned before, we're one of the oldest disciplines in the world. Funny enough, we're still data poor, which is completely contradiction, but it's just true because we as architects were never good in creating unified forms of collecting data, not like data science and these fields. We've done this now for decades. And also because architects are very, very difficult to convince to share data. For example, in my own case, with the ARI laboratory in Michigan, we did data collection to create our own AI models. And I've wrote to architects around the world asking them if they would share their data with us in order to improve the data set, and they would have access to it so they can actually train their own stuff, can do their own thing. It was impossible to convince them about that because it was like, oh, no, that's my IP, I cannot share it, and so on. That's impossible, cannot do that. And I don't want anyone to copy my stuff. And I told them, no one's going to copy it, no one's going to see it. I mean, I tried to explain to them examples from medicine where this gets done. And medical data is really tricky. I mean, it's very, you have to be very careful with medical data. And they still can do it. And I explained to them how and technically and so on. It was too early. It was not possible. Now, a couple of years later, we get the emails from big architecture companies asking us, hey, if we give you our data, could you help us optimize this and that? So there is change going on. I noticed that there's change, which means what I mentioned already before. The level of information about what this tool can do is slowly disseminating within the discipline in a way that finally I think we can do things that are a little bit more meaningful and powerful than just creating pretty images.
I like what you've said there too, because AI can be a little bit scary, but you have a 570-page book of all of these different ideas, and so you can start small. You can start with something extremely small and see, does it match what you've done in the past, and is it giving you good data, and kind of go off of that.
Yeah, there's a whole long chapter only about data collection, for example. Also, what it ethically means. Also, like how can we as the architecture discipline be a little bit more careful with what they do in terms of data, because we learn from the mistakes that computer scientists did like 40, 50 years ago.
I think one of the things that I'm very excited about, especially recently with the development of tools like Claude Code and Codex and, the Cursor, these different AI technologies that help people create tools, right? Not just provide answers or provide context, but actually create tools to solve problems. And I pair that with the students that you talked about at the schools that you've been at, and kind of having, once they kind of go through the process of your course, understanding the necessity of the pairing of the tool that makes tools and the people that guide that process, and then their possible future in the profession of architecture with that kind of know-how, right? Because the people who have been in architecture for a long time, for the most part, don't have that context. They don't have those skills. They weren't trained in that way. They don't think about problem solving like that. A lot of times architects are just starting with a blank page. They're coming up with a design. They end up, getting a permit for that. The building gets built. And then what do? We start another project at a blank page again, right? This is kind of the traditional model of architecture. And the students now that are coming into firms have what I would have considered to be superpowers, right? With their abilities to speak the language of AI, be able to develop tools as needed, and not have to buy that software off the shelf if it's not right, or if it's too expensive, or whatever. So I'm curious what you think about that, because I think I keep going back and forth, and like, what is the future for the next generation of architects? Are they safe? And I think you've started to address that here. But to me, those are the students that firms need to be looking at hiring, because they are the ones who are so capable of taking that firm to where it needs to go. As long as the architects who are there will actually give those students the agency to really help do that and not just plug them into a traditional architecture role of, I mean, it's great to get the experience of drawing details and drawing all of those things and learning how architecture goes together and helping that firm get to the next level and really listening to those students and allowing those students to mentor them to get their firm to the next place that it's going to go.
That's a good question. I mean, like one thing that I really want to point out is that it has to be said very clearly that just because we have this new technology, it does not mean that people are not allowed to make drawings on blank paper anymore.
Yeah,
I mean,
sure.
this is just, no one's going to take that away from you. Yeah, if you want to do that, do it. Nothing wrong.
That's
about
the
it.
ultimate agency. Yeah,
Exactly.
Right,
There's nothing
right.
wrong about that.
Right.
And I would also like to point out that you cannot believe how many students also resist in terms of doing these new technologies. They intentionally say, no, I want to do the drawing. I want to like get my hands dirty and I want to have this like visceral experience of designing. Yeah? And I understand that. Sure. I mean, if you want to learn a variety of different things while you're a student, you are totally entitled to do that. Yeah, there's nothing wrong about it. I'm just sometimes a little bit surprised when I really feel that students are intentionally pushing back against technology because I'm wondering about it. They actually grew up surrounded by it. They should feel naturally ingrained in that sort of environment, but they're not. Some of them, and it surprises me sometimes, like that I've had students who don't even know how to Google something. And I'm like, okay, this is strange. Yeah? But it seems to be that this whole fantasy that we had about the digital native, about the person who gets born into this whole digital environment might be more inclined and better in using this technology than we were, who were not born into this environment. Right. And I don't think it's true. Really? It's not true. It's a very strange phenomenon, but it's not true. It's there seems to be like a very strange resistance towards, but like for example, there's no resistance towards using these digital tools, but there's obvious resistance in understanding how it works. Yeah, and it reminds me a little bit of Arthur C. Clarke, who basically said that every highly like if a technology can be that advanced that at some point it doesn't it's not distinguishable from magic. Yeah. Mm-hmm. And it seems to be that when you do not learn how the technology works, it will always appear to you like magic.
Yeah.
I think that's also why a lot of people had this strange reception with AI. It seems like magic. You know, it's like I'm writing something and it answers to me and it makes sense. How is it possible? And it seems like magic, but then you explain to somebody that it's just basically calculating very fast the probability of the next word in the sentence. Oh, what is that? Why? What is probability?
Yeah, that curiosity of learning why the tool works the way that it does is interesting. And like that aspect of taking the technology for granted, like I don't use email, right? I only use text messaging, or I don't know what files are. Like I just look at the last thing I was looking at in my app, right? I don't understand folder structures, and there's many examples of the kind of thing that you're talking about. Was like one of my sons is in a Photoshop class, right? And it's like image generation for some people is just describe the image. For some people, it's compositing many layers together and understanding alpha channels and color correction and layers and all of those kinds of things. It's like the depth to which you could go to understand the tools is enormous. And so you really have to be curious to actually get to that point and not just take the tools for granted, because I think it's easier than ever with AI to take the tools for granted because it's just so good at coming back at you with a first blush of something that sounds or looks pretty incredible.
I mean, I want to say two things about that. I mean, first of all, I want to apologize because I'm a nerd. So I like to go deeper into the things and try to understand how they work technologically. You know, I understand if not everybody's interested in that. I get it. It's normal. That's okay. The other one is, despite my nerdiness, I'm still an architect. And there's one thing generally speaking, about architects that makes them extremely powerful as users of artificial intelligence, particularly the image generators. I understand why architects are so obsessed with image generators, because the knowledge that we acquire as in our education as architects about architecture history, art history, philosophy, technology, like all the sort of things that we have to learn through our studies are profoundly useful when you have to craft a prompt that generates a good image. We know about things like lenses and focal lengths and why does focus in the foreground and background, how to describe that in words. We have to write essays, so we have to be already quite adept in terms of using language. Architects are profoundly well equipped to use image generators. So I think this is one of the reasons why they're so obsessed about them.
Well, this has been a fascinating conversation. We're going to put links to everything that you mentioned in the show notes, so links to your firm, to your books. If you could just mention, though, for those who are listening, the best place to follow along with the work that you're doing with your new startup and with your architecture practice.
I think the best one, which I cater most to, is my Instagram account. Matias del Campo. If you look for Matias del Campo and span, you can find me right away. I think it's Matias.del Campo together, at Matias.del Campo. That's very good. If you want to go into the books, if you look up my name in Amazon, just write Matias del Campo and probably architecture or something. I'm gonna probably pop up as the first link there. And you have the links to all the books there.
Great. Well, thank you so much for having this conversation with today. It is really exciting what's happening in the field right now and the innovations that we can, like Candace, you mentioned. It's like just this barrage, this constant change. And it's like, wow, it's unbelievable how fast it is. And I know at some level for many architects, that's overwhelming, right? So everybody needs to jump on Dr. Del Campo's book. Only 570 pages of the way you can apply AI to the practice of architecture right now. And once again, thank you so much for joining us today.
Thank you very much.
It was a pleasure. Thanks for the invitation. Thank you.